Hey, what's up, YouTube fans? So a lot of times I enjoy making videos debunking arguments of irreducible complexity, right? And so irreducible complexity, for those of you that don't know, is a common creationist argument used to debunk in an attempt to debunk evolutionary explanations by saying that certain biological systems are irreducibly complex, meaning that they won't work unless you have all the parts together at once. Therefore, meaning that you couldn't have an evolutionary sequence of step-by-step leading up to it, because each step supposedly wouldn't be advantageous in its own right without all of the parts together, right? And so I've made a lot of YouTube videos showing how differing biological systems that they would claim are irreducibly complex actually aren't, right? And I've talked about differing fallacies of irreducible complexity. But so what I wanted to talk about in this video, right, is how part of what's sometimes missed when it comes to arguments of irreducible complexity, right, is that in order for a biological system to not be irreducibly complex, right, does not require that in every step along the way it was that you would still get the function that you currently get from it. All that's required is that each step along the way is advantageous in its own right, but the earliest steps, it doesn't have to have the same function as it now has. Just so long as it has some function, then it could be selected right through the process of natural selection. It doesn't matter at all if it has the function that it it doesn't matter if it originally had the function that it now has, right? So it's actually funny. So the famous trial Kitzmiller versus Dover, which was a famous trial court case on teaching intelligent design in science classes or not. And one of the people defending not teaching intelligent design in science class because it's not science, right? As a gimmick or whatever, he actually showed up to the courtroom with his tie. He had a part of a mousetrap that was like attached to his tie as a tie clip. He was using it as that, and it was mocking this thing that Michael Behe, which is one of the ones that was defending intelligent design, one of his arguments that he'll make a lot of times to give the idea of intelligent design, of how we can recognize intelligent design, is he'll show a mousetrap, and he'll show how a mousetrap doesn't work unless you have all the parts together at once. And so he'll say that therefore shows that it requires intelligent design. And so he says that that's how we recognize intelligent design, right? But so then what the guy at the trial there was showing is that even though without all of the parts together at once, it can't function as a mousetrap, nonetheless, if you take out some of the parts, it can function for other purposes, right? And in the case of evolution by natural selection, right, it doesn't matter if in the earlier steps it had the function that it now has, right? It just matters if it has some useful function, right? And there are many instances, right, where we can show that it didn't need to originally have the function that it now has in order to be useful. So a good example, how about the human arms and hands? In the earliest stages when these were evolved, they weren't arms and hands, right? And they wouldn't have been at all useful for arms and hands, right? If we were to judge them strictly as how could they be used as arms and hands, they would have been useless, right? But it doesn't matter because what they originally were legs and feet, right? And this notion is supported by the fact that the front legs and feet of many other tetrapods that are quadrupedal, their front legs and feet have the same fundamental structure as our arms and hands, right? And so that therefore means that the original structure that would have been evolved in the earlier steps could have just as well been useful if it was originally used as legs and feet, only later becomes modified into arms and hands. And so what's another good example? So how about with our nostrils, right? We now use them both for smelling and for breathing, but they didn't originally have to have both those purposes. In fish, they have nostril holes, which in them are called nares, but while they can smell through them, they cannot breathe through them. Tetrapods, including us, can breathe through the nostrils, and this is because tetrapods evolved a connection between the nostrils and the pharynx, which modified the nostrils towards also being able to be used for respiratory purposes, right? And in some lineages, the ability to smell through them was lost altogether, right? So in dolphins and whales, their nostrils went on to become a blowhole, and they can no longer smell through it, but they can still breathe through it, right? But so originally, when that whole, like the precursor towards it, when it was first evolved, it didn't have a breathing purpose, it didn't have a respiratory purpose, but that doesn't mean that it wasn't useful, right? And so it still can be explained evolutionarily, right? Or how about our ability to speak, right? The ability to speak, first of all, I mean, not all animals that can vocalize, like produce sounds for communication, have like a complex language like us. Some of them just like growl or, make noises of that sort, right? But in the earliest stages leading up to the earliest precursors leading up to the ability to vocalize, didn't originally have that purpose at all, right? But that doesn't make it problematic to explain evolutionarily, because we know that many of these same structures serve other purposes. The mouth, like the mouth hole, and then the jaws and teeth, the tongue, all of these serve digestive purposes just as much as they're good for, now we use them for speaking, right? But they're just as much good for being used for digesting food, right? Eating food, right? And so therefore, we have a perfectly good explanation for their original evolution, even though originally they weren't used for the purpose of speaking when they were first evolved. And then what's another example? So we now have evidence that that originally our ancestors had a cloaca, right, which is a single hole used for pooing, peeing, and reproducing. We still see this in monotremes, reptiles, birds, and amphibians. And during embryonic development, we start out having a cloaca, but it later divides into separate holes later into development, right? Which is why we poop out of a separate hole from where like babies come out of, right? But a chicken, it poops and lays eggs out of the same hole. But in any event, since originally there was a single hole for all of these purposes, when that hole was originally evolved, it didn't need to have all of those purposes at once. It may have only had one purpose, then became modified towards also serving these other purposes, right? And so, or how about another example? So we now have evidence that the malleus and incus bones of the mammalian inner ear are derived from the quadrant or articulate bones, which are found in most other jawed vertebrates. So mammals are unique in that we don't have the quadrant or articulate bones, so we have one lower jawbone, but we also do uniquely have, as mammals, we have the malleus and incus bones in our middle ear, right? Fossil evidence and developmental evidence now indicate that the malleus and incus bones of the mammalian middle ear are derived from the quadrant and articulate bones, right? And so originally, the precursor bones served totally different purposes aside from hearing purpose, right? But that didn't stop them from eventually being modified towards being part of the middle ear, right? Or how about there's some developmental evidence that the jaws and teeth were originally derived from modification of what was skeletal gill arches, right? So it was originally serving the purpose of helping the gills, right? But that was likely was later modified into the jaws and teeth, right? So again and again, we have examples of, or another example, the evolution of mesoderm, right? When it originally was evolved, there was no, it didn't, like develop into bone as it now does partly in us, right? It develops into the skeleton among other things, right? But in most invertebrates, they also have mesoderm, right? So again and again, we have examples showing that, whether or not something originally served the purpose it does now, that isn't relevant to whether or not each step along the way will be evolutionarily advantageous, right? And part of what can lead them to thinking that it would have to be the same function all the way through is because they're thinking within the framework of intelligent design, right? And so they're thinking of it as though that it's supposed to have this purpose, like intentionally, right? But it doesn't actually need to each step along the way have the purpose it does now, right? Just so long as it has a useful purpose, that's enough for it to be favored by natural selection. And so, all right, that's all for now. See you guys. Oh yeah, another good example I should mention, the lungs, right? The lungs, trachea, and bronchi. We now have developmental evidence that they are derived from the embryonic gut tube, right? We see that in development, right? And so, but the gut tube, it serves digestive purposes, right? So originally, when it was evolved, it wasn't at all having the purpose of helping with respiration, right? But then part of it later was modified towards that purpose, right? So that's another good example. There's the list, like I could, the list could go on all day of examples, right? But these are a lot of good examples. All right, that's all for now. See you guys.